Hello, this is Professor Werwath. I want to talk about software-defined architecture, but in particular, I want to show as an example how it's transforming the automobile industry, the automotive industry. I'm showing here a Tesla Model Y on purpose. I think the Teslas in particular have exemplified the value add that comes from software-defined architecture. When I was in the telecom business, we often talked about and even had a project called software-defined radio. So how can you literally have a phone, a smartphone that can be reconfigured in terms of its applications, the application layer, the control layers, et cetera, on the fly, with new software updates as well as new capabilities that are built into the software. So the software literally is defining how the product works, right? You're no longer dependent on how the physical wiring or the physical hardware is configured, but you're actually depending on how the software is adjusting how those physical parameters are implemented. So let's start with why are Tesla cars so appealing, right? Is it because it's an electric car? Well, I mean, honestly, that was not the first electric car, and it's certainly not the only electric car on the market. The Chinese has over 100 electric vehicles, not even models. We're talking 100 makes of electric vehicles. Of course, their market is much larger than the United States. I believe it's on the order of 50% larger, 60% larger. So we're maybe building, what, 16 million, cars a year. They're probably in the high 20s. So it's not because it's an electric car, and it's not necessarily because of their charging infrastructure. Even though that is a popular feature, there's a lot of infrastructure now that has nothing to do with Tesla, and Tesla is extending its infrastructure to support other vehicles other than Tesla. So their infrastructure is no longer uniquely slave to Tesla, and it's no longer a unique period in the marketplace, right? Is it because of Elon Musk? Well, I mean, there's a lot of businesses that Elon has touched, including Twitter, that have failed or fizzled or are fizzling. So you got to wonder, it can't be because of Elon Musk. It might be that Elon Musk has brought attention to the industry and brought attention to EVs in a way that nobody else has. I would argue it's the last one here. It's because of the software-defined architecture, right? The product continues to evolve after you take delivery. So what it does today is it's no longer constrained by how it worked out of the factory. It can literally have software updates over the air that change functionality, that add features, that add capabilities that didn't exist before, right? And there's lots of examples of that. But I mean, a simple one might very well be how they use the cameras on board the vehicle, right? So you've got something called Tesla Cam that has, in essence, turned the car into a security agent, taking pictures, video of all the surroundings at all times, 24/7. I don't know of any other car that has the Tesla Cam capability or that kind of sentry mentality or sentry mode where you can literally monitor the ongoings of the car, whether it's turned on or turned off or whatever. So those sorts of things are allowed and enabled because of the software-defined architecture. A traditional network has data and control planes that are, in essence, decentralized. Okay, so the data and control are bundled together. An example might very well be windshield wiper blades or electric motors on the windows, or it could very well be, any other, automatic defroster, whatever you want to call it, whatever feature or function. Those have been decentralized historically, right? So you can literally take the electric motors for the windows and apply them to different vehicles and plug them in. And they're controlled locally, not centrally, okay? As opposed to a software-defined network where these things are all controlled in a centralized controller. So you have one computer in the middle that is controlling all these other data planes and all these other application layers, right? So the control is centralized, even though the applications may be decentralized. So here's another example of that where the applications are basically separate from each other, but the control plane is consolidated, it's centralized, right? And again, the data plane is decentralized. So while control is centralized, what that means is you have a single user interface, right? And in this case, It's the command center of the Tesla Model 3, Model Y, which is effectively a screen, a user screen that has, entertainment, what they call infotainment, right? As well as HVAC controls and all these peripheral controls that I just mentioned earlier, the windshield wipers, the headlights, the motors on the windows. So all of those things are centrally displayed and centrally controlled, right? What are the advantages of that? Well, we'll see in a minute. First of all, let's understand it a little bit more, right? Software-defined architecture is an approach that decouples hardware components from the software that controls them. So in the old days, if I bought a window motor, along with it came a tiny bit of software from the window motor control people, and those two things were coupled together. And in no way did I, as a supplier, define how that software would work, right? And it was so decentralized that it would be very difficult, if not impossible, to update it. Software that controls them, allowing for greater flexibility, scalability, and efficiency in automotive systems. So you're decoupling hardware components from the software that controls them. In the automotive sector, SDA enables the development of intelligent vehicles, right? Advanced features such as autonomous driving. So imagine steering and braking, as well as all the other mobility features of acceleration and deceleration are all centrally controlled, right? Because the control layer has now been centralized as opposed to decentralized, right? You can do over-the-air updates. Those over-the-air updates are not just for infotainment, right? But they're also for every function, virtually every function of the car, right? Enhancing the overall experience, letting it evolve over time. Software moves much faster than hardware, right? So when you ship a car, you were freezing in time the way the hardware was configured, the way it was intended to operate at the time of manufacture. And if you've got I've got an 8-year-old electric car and I got a 2-year-old electric car, right? Without SDA, those cars are frozen in time, right? In 2016 or in 2022, depending on which car you're talking about. Implementing SDA in vehicles requires seamless integration of software and hardware, ensuring compatibility, security, and real-time responsiveness to meet the industry needs. So now we have a bit of a systems problem here, potentially, because you're bringing together through a central control layer the control of all of these components in the vehicle. So you got to make sure that you have the right, as it mentions, right, performance in terms of hardware, compatibility, security, responsiveness, et cetera. So those things become quite essential. So what are the advantages, right? So it leads to streamlined development, reduced hardware costs, enhanced software updates, improved cybersecurity, increased vehicle customization options, right? If you don't like the way your car brakes, right? You think it's too abrupt, you think it's too soft, those things can be adjusted, not through hardware, like in the good old days with an Allen wrench or with a screwdriver. No, you're going to be updating it through software parameters that can be defined by the user. You can soften it, you can harden it, you can make it more robust, whatever you want to make it. So you have electronic control units that manage specific vehicle functions like engine control. You have software frameworks that provide the foundation for developing modules and applications. You have sensors and actuators that enable data collection and interaction. You have communication protocols that facilitate data exchange. And you have cloud services that support remote updates, data storage, and connectivity features. These are the key components, right? Some people might say you can take this kind of architectural approach to how organizations work. So think about how if you could create organizational dynamics that were architected along the same lines as SDA, what would that mean for the organization, right? Much more nimble, much more able to have centralized control and at the same time decentralized performance and actuation, and centrally be able to make adjustments in terms of what information you're collecting and what you're going to do with that information, right? So performance improvements, you have increased safety and enhanced vehicle efficiency, right? So through SDA, right, automotive manufacturers can enhance safety through driver assistance, collision avoidance, automated emergency braking, and intelligent traffic management. Yes, you could do these things in a decentralized way, but it would be hardly well coordinated. It would probably be more hit or miss. And frankly, these systems could be working against each other unless you have centralized control. So you can have these features in a decentralized way, and I've seen it done, and it can be done well. The problem is, again, it's static. It's frozen in time. It's never going to change, right? SDA optimizes vehicle performance by enabling real-time data processing, predictive maintenance, adaptive systems, and energy management. You have more efficient and reliable vehicles as a result. Some of the challenges: security, of course. Anytime you centralize anything, you're implementing software-defined solutions. You're raising security challenges, related to data protection, cybersecurity risks, unauthorized access, the need for robust encryption, right? Legacy system integration. How do you integrate the new SDA architectures with existing legacy systems and planning? You got to be very careful with backward compatibility measures, potential system upgrades to ensure seamless transition. And in terms of regulatory, right, complying with regulatory standards, industry standards, data privacy laws, necessitating continuous monitoring, assessments, and updates to meet legal requirements. So what's the future outlook look like? Well, autonomous driving systems, right, these are projected to grow rapidly, somewhere in the order of 40% increase in adoption over the next 5 years. Predictive maintenance software and automated automotive systems is forecasted to increase by 20%, improving operational efficiency and reducing downtime through proactive monitoring and diagnostics. So I think the future is bright for software-defined architectures. So here's the question, right? How can this apply to your industry? How can this apply to your products and your portfolios? Can a software-defined approach, like in telecom, like in automotive, like what we're seeing in smart devices of all sorts, especially our most favorite one here, right? The smartphone itself. How are these benefiting from SDA, and how can your business benefit? Give it some thought, and I'll see you in class.